Okay, let's get started. So last time we were talking about a way of doing clustering that actually uses matrix factorization concepts which were closely related to what we saw with PCA. So in this case, of course, we'd be working, if we're doing document clustering, then we'd be working with an X that was our TF-IDF matrix, where we would have documents going down the rows and then terms in our dictionary going across the columns. And in the last unit, we studied PCA, which is a way of approximating this matrix X using a rank R matrix that is a product of a tall matrix with orthonormal columns, a diagonal matrix with positive entries, and then a wide matrix with orthonormal rows. And this was the SVD, is how we get this decomposition. And then we said there's an alternative approach that might make a little bit more sense in this application, because in this application we know that we have a positive matrix X here. And so the problem is, if you start with a positive matrix X and you approximate it in this way, there's no guarantee that this approximation here will give you a positive approximation of this. So, or, non-negative. So that, casts some suspicion on this. And so we said another way to do this is to write X or to approximate X as a product of some tall matrix W and some wide matrix H. They both have R rows or columns, and force these two things to be non-negative. That way, if you're taking a non-negative combination of non-negative terms, you're guaranteed to get non-negative things in the approximation. So this is an alternate approach. Because there's more constraints here, there's these non-negativity constraints that the PCA does not have. We expect that if you looked at like the RSS of this approximation relative to the true X, it's going to be worse than this. But the positivity or the non-negativity of terms might be more important. In fact, we did the experiment. We looked at this, how well this worked, and we found that PCA didn't seem to work well in this problem, but when we did non-negative matrix factorization, we got really nice clusters that were actually nicer than what we got with k-means. So this is a cool method, and what I want to talk about next is just other ways you can think about it and other applications that you could approach with this non-negative matrix factorization. Okay, so coming back to the face, approximating faces, we can think about what PCA and non-negative matrix factorization are doing with faces. And this is just useful because I found these nice pictures in this paper that came out to try to explain